All right, good notes for section 11.2, which is the vectors in the plane. So we'll start with two-dimensional vectors. That should be while. So while the pair AB determines a point in the plane, it also determines a directed segment or an arrow. With this tail of the origin, the head at A, comma B. The length of this arrow represents the magnitude, while the direction it points in represents direction. In this way, the ordered pair A, comma B represents the mathematical object with both magnitude and direction, called the position vector of A, comma B. So we've got the two-dimensional vector. Two-dimensional vector V is an ordered pair of real numbers denoted in component form as angled brackets A, comma B. The vectors A and B are the components. The standard representation of the vector is the arrow from the origin to the point A, comma B. The magnitude or absolute value of V, denoted by absolute value V, is the length of the arrow, and the direction of V is the direction which the arrow is pointing. The vector 0, or 0, 0, it's called the zero vector, has zero length and no direction. It's just a point at the origin. So if we find the magnitude of a vector, so the magnitude of the vector A, comma B is the square root of A squared plus B squared. Because you can think about essentially drawing a right triangle where A and B are the two legs, and you're finding length of the hypotenuse. The direction angle of a non-zero vector V is the smallest non-negative angle theta formed with the positive x-axis as the initial ray and the standard representation of V as the terminal ray. So just some more definitions. All right, head minus tail rule. If an arrow has initial point x1, y1 and terminal point x2, y2, then it represents the vector x2 minus x1, y2 minus y1. So the head of the tail, or head minus the tail. So the head of the arrow minus the tail gives you the vector. Okay, example 1. Find the magnitude and the direction angle of the vector V, 1, negative 1, comma, root 3. Okay, so let's find magnitude V. So the magnitude of V is equal to the square root of the components, or the sum of the components squared. So that's the square root of 1 plus 3, which is the square root of 4. So the magnitude of this vector is 2. Okay, now to find our angle, let's see here. If you think about what the vector does, it means we're going, so negative 1 and then up root 3. So we're looking for the angle in here. Now we'll have to do some corrections, but this is opposite and adjacent. So that's the tangent of my angle is equal to the opposite over the adjacent. So theta is the inverse tangent of root 3 over negative 1. Let's put ourselves in degrees here. So the inverse tangent of the square root of 3 divided by negative 1. Now, calculator will give you negative 60. But that angle is not negative 60. It's actually, that piece there is 60 degrees. But since we measure from the positive distance here, this full distance is 180. We have to come back 60. So our actual angle is 120 degrees. So you will potentially draw a picture to figure out what your angle actually is. You cannot just trust your calculator because the angle is positive angle. Can't have negative 60 there. Alrighty, find the component form of a vector with magnitude 3 and direction angle 40. So we're kind of going backwards here. So we know that this is true, so we have a 40-degree angle, and we know that the magnitude is 3. So I need to find the component form, so I need the y value and the x value. Well, y is the opposite, so I could say that the sine of 40 is equal to y over 3. X is the adjacent, so the cosine of 40 is equal to x over 3. Then I can just solve these equations. So this would give us y is equal to, multiply both sides by 3, so 3 sine 40. This is 1.93. And the x value is going to be 3 cosine 40. So that's 2.2, now that's 1.928, so we can go at the same places. 2.298. So the vector is 2.298, comma 1.928. Now remember, vectors have angled brackets, so not parentheses would be what ordered pair lies at the end of this point, but that's not what it's asking. All right, so some vector operations. So let U be U1, U2, V is V1, V2, and be vectors, and K be some real number or a scalar. The sum, so if you add U and V, you just add their matching components. Same thing works for difference. The product, that should be a product of the scalar K, you just distribute into the vector. These opposite of vectors, negative V or negative 1 times V. So that's how you do subtraction. So you add the opposite vector, but it's the same thing as regular subtraction. Okay, the vector V over the magnitude of V is a vector of magnitude 1 called a unit vector. Unit because that's length 1. Its component form is cosine theta sine theta, where theta is the direction angle of V. For this reason, V over magnitude V is sometimes called the direction vector of V. So it points in the same direction but has length 1. So let U be negative 1, 3, V be 4, 7, find the following. So 2U times 3V, or 2U plus 3V, so 2 times vector U plus 3 times vector V. So this would become negative 2, 6 plus 12, 21. And then we just add matching components. Negative 2 plus 12 is 10. 6 plus 21 is 27. Okay. So U minus V. So vector U, negative 1, 3, minus vector V, 4, 7. So it's just matching components, negative 1 minus 4. So negative 5, 3 minus 7, negative 4. Now the other way to think about that, and the way that it was in the text box, was be instead you add the opposite vector, but you get the same thing. Negative 1 plus negative 4 is negative 5. 3 plus negative 7. All right, so the magnitude of half U, so this would become the magnitude of 1/2. So U is negative 1, 3. So this would be the magnitude of negative 1/2, 3/2. So to find magnitude, that's the square root component squared. So this is square root of 1/4 plus 9/4, which is the square root of 10/4, which is root 10 over 2. So there you go. All right, properties of vector operations. So U plus V is the same as V plus U. Add 0 to a vector, or add the 0 vector to a vector, you get the original vector back. Multiply a vector by 0, you get the 0 vector. And those bolts are for vectors, non-bolts are for numbers. So if you have two scalars multiplying U, you can multiply the scalars together first. I'm actually kind of going out of order, aren't I? This lets you distribute your vector into A plus B. So you can change what grouping is. Adding a vector and its opposite gives you the 0 vector. Multiplying a vector by 1 gives you the original vector. And you can distribute in as well. Okie dokie. So modeling some planar motion. Example 4 here. Boeing 727 airplane flying due east at 500 miles per hour in still air encounters a 70 mile per hour tailwind acting in a direction 60 degrees north of east. The plane holds its compass heading due east, but because the wind acquires a new ground speed and direction. What are they? So what we've got here is we need the component forms of our vectors. So for our airplane, the airplane is flying due east, so that's in the positive x direction, so 500, 0. So east, west, north, south. The wind would be, the vertical amount would be 70 times the sine of my angle. Whoops, nope. Horizontal first, so cosine. And then 70 sine 40 over here. So let's see here. So this is actually, that 40. Oh, I said 40. It's 60 degrees. All right, so the cosine of 60 is 1/2. So this is 35. The sine of 60 is root 3 over 2. So this is 35 root 3. So the plane's resultant vector would be if I add these two things together. So horizontally, it's going 535, 500 plus 35. Vertically, or north-south, it's going 35 root 3. So to figure out new ground speed, so the ground speed is the magnitude of this. So the square root of 535 squared plus 35 root 3 squared. So our ground speed is the square root of 535 squared plus 35 root 3 squared. So the new ground speed is 538.42 miles per hour. The direction is the inverse tangent of b, the y value, over the x value. So the inverse tangent of 35 root 3 divided by 535, we get 6.5 degrees north of east. As you're measuring, remember you're measuring from that way, so it's north of east. Okay. And no fancy adding or subtracting things because these angles are in quadrant 1, so this value will give you the exact same, will give you the correct value. All right, so example 5, particle moves in a plane to this position any time t greater than 0 is given by sine t, comma, t squared over 2. Find the position vector of the particle at time t. So let's see here. So the position vector is just going to be where the thing is, so it's actually just the vector version of your point. Find the velocity vector. So to find the velocity, we need the derivative. So that's going to be cosine t, comma, t. Acceleration is the derivative again, so negative sine t, comma, 1. Okay, describe the position and motion of the particle at 6. So let's see here. So the position of the thing is at sine 6, comma 18. Oops, be an ordered pair. The velocity, this one would be a vector. Velocities are vectors, would be the cosine of 6, comma 6. And the acceleration would be the negative sine of 6, comma 1. All right, so velocity, acceleration, and speed. So position, velocity is the derivative, speed is the magnitude. So speed is a scalar, not a vector. Particle's acceleration vector is the second derivative. Particle's direction of motion is the direction vector. So there you go. Okay. So, example 6, baseball leaves a batter's bat at an angle of 60 degrees from the horizontal, traveling 110 feet per second. The fielder, who is standing in the direct line of the hit with his glove at a vertical reach of 8 feet, catches the ball for the out. His feet do not, so he stands on the ground. Find the position vector of the baseball at time t in seconds. So, let's see here. So, since we're hit at an angle, the position vector is going to be 110 cosine 60, 110 sine 60. No, sorry. We need our t's. You know how fast it's going, so you know how long it is. So this is going to be cosine of 60 is half, so this is going to be 55t comma, 55 root 3 t. Oops, forgot my vertical gravity ax, so minus 16t squared minus 16t squared. There we go. Okay, it's horizontally gravity as an ax, so I don't have to worry about it keeps going however much is initial. So this is the initial horizontal velocity. This part here is the initial vertical velocity, but vertically gravity acts, so that's why I need the minus 16t squared. Velocity vector, so that's the derivatives. So the derivative of this would be 55 horizontally. Over here, that'd be 55 root 3 minus 32t. At what time t does the fielder catch the ball, and how far is he from home plate? Okay, so in order to do this, we know that the vertical position, so this, oops, lost my t, has to be 8, because that's one that goes in his glove. So let's see here, what are our possible solutions for this guy? Oops, no, I want to graph, I want to solve. So essentially this is a quadratic, so this becomes 16t squared minus 55 root 3t. So we're bringing everything to the right technically, but we'll write it this way. So t equals 8, or equals 8. So actually we can just graph it. 16x squared minus 55 root 3x plus 8. So t can be let's see here. .89. There's actually another time over here at 0.09 seconds, but that's right after it leaves the bat. So that's what time he catches it. How far is he from home plate? Well, now we know t, we can plug it into our position vector. So 55 times t, so he is 55 times 5.89. He is 324, about 324 feet. From home plate when he catches the ball. How fast is the ball traveling? So this is the velocity. So my vector would be 55 because that doesn't change. This part I have to plug in my t. So 55 root 3 minus 32 times 5.89. So negative 93.22. Now, which makes sense because it should be coming back down. So the magnitude of this is the square root of 55 squared plus negative 93.22 squared. So that ball is going 108.2 feet per second. All right, example 7. A particle moves in the plane with position vector, blah, blah, blah. Find the velocity and acceleration vectors. Well, the velocity vector is the derivative, so that's going to be derivative of sine as cosine. So it's going to be 3 cosine 3t, comma, derivative of that's going to be negative 5 sine 5t. The acceleration vector is going to be negative 9 sine 3t, because another 3 comes out, comma, negative 25 cosine 5t. So there's your equations. Okay, 8, particle moves in elliptical path, so its position is given by this. Find the velocity and acceleration vectors. Okay, well, velocity is the derivative, so that's going to be 4 cos t, comma, negative 2 sine t. The acceleration vector is the derivative again, so negative 4 sine t, comma, negative 2 cosine t. Find the velocity, acceleration, speed, and direction of motion at pi over 4. All right, so the velocity, I plug pi over 4 into my velocity equation. So the velocity is going to be 2 root 2, comma, so at pi over 4, these are all root 2 over 2's. So 4 times root 2 over 2 is 4 root 2 over 2, which is 2 root 2. Negative 2 would just be negative root 2. So there's velocity. Acceleration is going to be negative 2 root 2, comma, negative root 2. Speed. So speed is the magnitude of the velocity. So that's the square root of 2 root 2 squared plus negative root 2 squared. So 2 root 2 squared plus 2 is root 10. So where are we here? Okay. So, and the speed. So speed is the vector divided by its own magnitude. So it's going to be, oh no, whoops, I did speed. That is speed. Direction of motion, sorry. No, that essentially covers it. Sketch the path of the particle and show this velocity. So the path of the particle, let's see here. X equals 4 sine t, so it's going to do that. So at 4, 0, it's actually going that way. That was clockwise. I drew it backwards. It goes this way, so it should be coming straight down. All right, displacement and distance traveled. So here's some more formulas. So displacement, integrate the two vector components separately. Distance traveled is the integral of the magnitude. So looks like this. All right, so particle is moving in a plane with velocity vector, blah, blah, blah. T0, the particle is at point 1, 5. Find the position of the particle at t equals 4. So let's see here. So displacement is equal to from 0 to 4 of t minus 3 pi cosine pi t, comma, from 0 to 4, whoops, dt. 2t minus pi sine pi t dt. So that's my displacement vector. So if I work these out in my calculator, go back to radian mode here. Option, calculator, integral x minus 3 pi cosine pi x from 0 to 4. This one gives me 8. If I do the other one, it actually ends up giving me 16. So that's the displacement vector. So if it starts here, it's going to move 8 horizontally. So now it's at 9, comma, 21. Distance traveled is going to be from 0 to 4, the square root of t minus 3 pi cosine pi t squared plus the second component. So that formula. So the integral of the square root of the quantity x minus 3 pi, whoops, cosine pi x close quantity squared plus quantity 2x minus pi sine pi x quantity squared from 0 to 4. So this comes out to be about 33.5. So that's where it ends up, but the distance it travels is that because it takes a lovely curvy path. All right, sample 10, determine the path of the particle, sample 9. So essentially you just looking at the graph. So that problem gave us our velocity vector. Was t minus 3 pi cosine pi t, comma 2t minus pi sine pi t. So that was our velocity vector from before. So to find the position, essentially it wants the position vector, the r of t, which means we need to do the antiderivative. So this would be 1/2 t squared minus 3 sine pi t, so this pi essentially moves back in. This one would just be t squared plus cosine pi t. Let's see here. Oops. Plus c. So when t is 0, we have to be at this point. So if I put 0 in for these t, this c value has to be 1, because this would be 0. This would be 0, which means in order to get to be a 0.1, my c value has to be 1. This one, if t is 0, this becomes 0 plus 1 plus c. And I need that to equal, this becomes, 0 plus 0 plus c, but it has to be 1, so c has to be 1. 0 plus 1 plus c has to be 5, so c for this side over here has to be 4. So that is my position vector. And then if you graph this, ordered pair parametrically, you would get the path that the thing takes. Let's see if we can find it. Delete type parametric. So the x value is 0.5x squared minus 3 sine pi t plus 1. The y value is t squared plus cosine pi t plus 4. Zoom out. So there's our path. Now if I wanted to go to the setup, whoops, you can probably somehow set the, this is graphing the whole thing, it's not graphing only between, but you can trace along to find the path where it hits 9, 21. It's just gonna be about over here. So there's your 921. So that graph shows the path the thing would take. And that brings us to the end of the section.